Hi guys. Today I'm going to show you how to use the law of cosines to find a missing side or a missing angle in any triangle. These triangles are generally going to be non-right triangles, so they're not going to have a 90-degree angle, and we cannot use SOHCAHTOA. The first thing I want us to understand is that the capital letter is for the angle, and then the side opposite has the lowercase same letter. And then our formula is going to be c squared equals a squared plus b squared minus 2 times a times b times the cosine of angle C, where the capital letters are the angles and the lowercase letters are the sides. Some things I want us to remember. Okay, always draw a picture unless they've given you the picture, and then I want us to label it so that we know exactly what each side length is and what each angle measure is and what are we trying to find. And since these are not right triangles, we're going to use the law of cosines. So here's our first problem. Triangle ABC has side lengths of 5.3, 6, and 8, as shown at the right. Find the measure of its largest angle. So we learned in geometry that the largest angle is opposite the longest side. So we're going to be looking for angle C in this problem. So the first thing I would do is I would write down the formula and substitute the values that we know. So we know that length C is 8, and length A is 5.3, and length B is 6. And I substitute them all into the formula. I then evaluate, I square all the numbers I can, I do my multiplication steps so I can simplify the problem. And I get to the next step. I then do more algebraic manipulation where I combine like terms, I add and subtract from both sides, I divide, and that gets me my next few steps to eventually I'm left with the cosine of C is by itself. And then we learned last week that we can use inverse trigonometry to get C by itself by taking the inverse cosine of both sides. Now it helps to go out a few decimal places. I generally write the first 4 non-zeros. Rounding is not going to be a big part of this unit, but the more decimal places you go out, the more accurate your answer is going to be, so that when we take the inverse of both sides, we wind up getting that C is approximately 89.9 degrees. In our picture, C looks like it is about a right angle, so the picture in this case looks pretty good. Okay, when you're drawing your own picture, assume it's generally not going to be great, so you got to be very careful with your algebra steps. And always make sure you show a lot of steps so that you can see where your mistake is. And also make sure your calculator is in degree mode when we're dealing with triangles that are asking for degrees. Please look at the rest of the notes, and if you have any questions, I'll keep setting up Google Meets, and we'll go from there.